Okay, let us now implement the AddLast method. Now, if the linked list is empty, the things are going to be just same as AddFirst. We need to create the node. That's the first thing that we need to do here in AddLast as well. So I'll just copy the content from the AddFirst. So up to this point, everything is going to be just same. So let me just copy that. We need to just change that else part. So here you can see we have created the node in the same way as we did in case of AddFirst method, and then we put that data into the node, and then we initialized both the next and the previous field with null. And if the linked list is empty, the treatment is just same. That means assign the address of this new node to both head and tail. Otherwise, if the linked list is not empty, then what we need to do is to add this new node at the end of the linked list. So let us draw a picture there and try to understand the logic first, then we'll go for the implementation. So here is the situation. You can see the picture. There are 3 nodes in the linked list, and they are already existing in the double linked list. As you can see, the first node's address is 1000 and head contains 1000 there, and the previous to the first node is null, and also the last node is actually 3000. That's the node, and the tail contains 3000. That's the address of the last node, and we have this new node that is pointed by P, right, in the color green. So that's at address 4000, and P is pointing to this. So we need to add this new node. Say the content of this is 30, and we need to add this new node as the last node of this linked list. So we need to update the tail pointer this time. So what's going to be the code? We actually need to put the address of this new node, that's 4000, here. I mean, in the next pointer field of the current last node. So we can access that by using the tail pointer. If I write tail arrow next, that means it is the next pointer field of the last node, and that should be assigned with P. So what we are doing, we are copying the content of P, that is 4000, here in the next pointer field of the current last node. So 4000 comes here, and this points to this. Now we need to update this previous pointer field of the new node. So that's going to be something like this. P, that's the last node's address. I'm sorry, that's the new node's address, arrow prev, and we are referring to this location, the previous pointer field of the new node. That should be actually tail. That's the address of the current last node, and that is 3000. So we are assigning 3000 here, and this is going to point to this. Okay, and then we need to update the tail. Tail should point to this new node, so tail equals P. So 3000 is no longer there in tail. P, that is 4000, is assigned here in tail. So tail is now pointing to this new node. That's the last node. So tail is not pointing to the previous last node. So we have added the new node as the last node of this double linked list. So that is the logic by which we can add a new node as the last node of the linked list. So let's go ahead and write this code there in the else part. What we need to do is to update that tail arrow. Again, I'm doing the same mistake. LSTPTR arrow tail, arrow next, that should be actually P, and P arrow prev, that should point to tail, and then we need to update that tail with P, and we need to increment that node count by 1. So lstptr arrow node count, that should be ++. So we are done with this. I mean, we have written the code for adding a new node as the last node of the double linked list. So pause here and write this code in your IDE, and then come back again and see how we can test this. I have already written that code. I mean, I have already written the call to these functions there in the main function, and we have the menu there. So I'll show you how we can run that. I'll call the option 2, that's going to create the linked list with some random numbers. You can see that the create list from random numbers, that function has been called from option 2, and also from that particular function, create list from random numbers, we are actually calling that AddLast method, as you can see at line number 132. So we have written that AddLast method right now. So that's going to work, and it will create the linked list. Okay, so, and we can do that obviously right now, but in order to view the linked list, whether it has been created successfully or not, we need to write at least one of the display functions there. I mean, it can be the print list details or list forward or list backward, either of these 5 or 6 or 7 that we need to write in order to check whether the linked list has been created successfully or not. So I'll be doing that right now. So I'll just write the print forward. This is going to be a simple one. Okay, so let me copy that. I'll go to the end of the file and I'll paste it here and I'll implement this. So I'll take a node pointer there, P, and I will assign lstptr arrowhead. So the P is right now pointing to the first node. It's going to be exactly same as the display function that we already written there for the single linked list. So we need to write a while loop, or you can go with the for loop as well. We need to iterate through the linked list as long as there is a node. And if P is null, we need to just stop the while loop. So first of all, have a checking there. If P is null, we can just print the linked list is empty and can return from this function. Otherwise, we'll just display the content of the linked list. Let's have a heading there, and inside the loop we'll just print content of each node one after another. So p arrow data, that's going to be the access to the data field of the current node pointed by p, and we will move to the next node. P equals p arrow next. That will take us to the next node, and we'll just write an end there. So that's how we can just traverse through the linked list. I'll just go ahead and write another operation, that's the print reverse. That's going to start from the last node and will traverse through the linked list until that reaches to the first node. That's going to print the whole linked list in the reverse order. So let me just do that. It's going to be a quick one. So I'll just copy the prototype of that print reverse. So here's the implementation of print reverse. And we need to just do it starting from the end of the linked list. So I can just copy the code of print forward and paste it here, and we'll assign tail instead of head. That means we want to start from the very last node, and the address of the last node is there in the tail pointer. So the rest of the thing is just going to remain same, content of double linked list in the reverse order. And as long as there are nodes, so p arrow data, instead of p equals p arrow next, we should move to the backward direction, and that is going to be possible using the previous pointer field. So we are going to hop from the current node to the previous node. So here it is. Now we are all set to check all these functions so far we have written. So we'll do that. Keep watching. Okay, little correction required. The same thing, lstptr, you can see that there at line number 266. I made that a habit, making the same mistake again and again. So it should be lstptr arrow tail. We cannot access tail directly, right? It's there inside the structure object, and the pointer is passed to this function, and that's there in lstptr. So in order to access head or tail, it should be lstptr arrow head or lstptr arrow tail. So I got this error actually while compiling this file. So let me just compile again, gcc. Okay, we got this error, right? Now it is saying that redefinition of init list. So actually I have implemented this init list twice. One that I did earlier before starting this tutorial, and during the tutorial, the last one, I also implemented this one again. So I need to delete one of the implementations. I cannot have two implementations there for the same init list function. As you can see that it's there as well. So I'll delete this one. Okay. So check that you do not have two implementations of init list there in your file as well. So I think we are good with this, and let me check if that is okay. So gcc and then dbl list.c. So we have something more, and it says that print list details Okay, actually what is happening here, I have called all those functions there which are not yet implemented. So as long as they are not implemented, they are going to show errors. So what I'm going to do here, I have implemented this add first, so the call is going to be successful. This is also done. So print list details, we have not done this. So I'm going to comment out this section that we have not done yet. We did the print forward there, and also we did the print reverse as well. So I need to add that menu, I mean the case option here. The print reverse is actually there at option 7. So we need to just add a case 7 there, and we need to call that print reverse function. And we need to pass the address of that list object. And a break to break the switch. Okay, let's check this. So just reset the console and then go again with the compiler. Here we go. It has been compiled successfully. So we'll be running this now. So here we go, ./a.out, and here is the menu. So we'll use option 2. We do not have a file there in our current directory. If you want to use option 1, that's going to run okay. And in that case, you need to just have a file there, text file containing some numbers in the current directory. And when you give that option 1, it will ask for the file name, and give that file name there, and it will load the data from the file name and will create the linked list. I'll check using option 2. So you can see that it is asking for the number of items to be generated randomly for the linked list. I give 5 there, and now the linked list has been created. So I'll use option 6 to print the linked list in the forward direction. So here it is. Now if I want to print the linked list in the reverse direction, option 7 is there. You can see that the linked list has been printed in the reverse direction, exactly in the reverse direction. So I can go ahead and use option 3 to add a new node as the first node. So I'm just giving 100 as the node data. So now I'm again displaying that in the forward direction. You can see that 100 has been added as the first node. Now I will use that AddLast operation, that is menu option 4. So here we go, AddLast, and I'll check that I'm just adding 300 there. So I'll just display the linked list once more, and you can see that 300 has been added as the last node of the linked list. So we have successfully implemented the add first, add last, and both the printing operations there. And as I said, if you want to use that option 1, loading from the file and creating the linked list, just have a file there in the current directory with some numbers, as we did in case of single linked list, and choose that option 1, and it will ask for the file name, and give that file name. It will create the linked list by reading all those integer numbers from the file. So that's all for this. In the next tutorial, we'll be actually implementing the search operation. That's the find operation. Thank you for watching.